Hi there. In our last section, you learned how to find the different types of equations of plane. In this section, you are going to learn how to prove that the two lines are coplanar. So let's begin. Coplanarity of two lines. At first, you are going to learn the vector form of coplanarity of two lines. So let's begin. Vector form. Let L1 and L2 are two lines with equations. Vector R is equal to vector A1 plus P vector B1 and vector R is equal to vector A2 plus Q vector B2. Then the two lines are coplanar if and only if vector A2 minus A1 dot vector B1 cross B2 is equal to 0. In other words, we can say that if you find the cross product of vector b1 and b2 and then find the dot product of the difference of a2 and a1, that should be equal to 0. And if that's the case, then these two lines are coplanar. Now let's talk about the Cartesian form of coplanarity of two lines. So let us consider the coordinate of 2 points P x1 y1 z1 and point Q x2 y2 g2 respectively. Then a1 b1 c1 and a2 b2 c2 are the direction ratios of vector b1 and b2 respectively. So if you see, this is the vector b1 and this is the vector b2, then the given lines are coplanar if and only if the determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 is equal to 0. In other words, the two lines are coplanar if you create the determinant using q and p and these direction ratios and the value of that determinant is 0, then the two lines are coplanar.